Hey, Wagwan. Yeah, man. Mr. Garfield here. And today we'll be looking at a CAPE integrated mathematics question. All right. And I'm focusing on module 3, that's calculus. Okay. And I want to look at limits of piecewise functions. All right. Sometimes this topic can be difficult for students. All right. So I just want to go through an example. Okay. So it says, given that f of x is equal to this here, determine the following where appropriate, right? And it asks us to calculate some limits. And part 4 is a function defined at a particular value. Okay, let's do part 1 here. All right, let's do part 1. So part 1, solution. Part 1 says where to find the limit. The limit all right, so the limit of f of x as x approaches 2 from the left. All right, x approaches 2 from the left. So I'm going to go to my number line over here. All right, so I'm going to draw a number line and we discuss what that means. All right, I'm going to discuss what that means. Good. So let's say this is my point of reference 0. I will have -1 here, -2 here, 1, 2. All right. So this is 2. And this is the real number line. All right, the real number line. And for the real number line, it goes from -infinity, okay, from -infinity to +infinity, okay, good. And I'm approaching 2 from the left, okay, so this is the value here, 2, all right. Now, when we approach 2, right, in maths, when we approach a value, we can either approach it from the left-hand side, all right, or we can approach from the right-hand side. All right, great. So you should know that, okay? Let me go back over here. Right. So if I'm approaching 2 from the left-hand side, all right, it means that I'm focusing on the values of x that are less than 2, right? And if I'm approaching from the right-hand side, it means that I am focusing on the values of x greater than 2. Okay? I hope that is clear. Because let's say I want to approach 2 from the left, right? And I choose a value like 1.5, all right? Or 1.9 or 1.999, right? That is to the left of 2, okay? If I'm approaching 2 from the right, I can choose a value such as 2.01, right? And I can get even closer, okay? And that is to the right of 2. Good. So if I'm approaching 2 from the left-hand side, it means that I'm focusing on the values of x, which is less than 2, right? I'm approaching 2 from the left-hand side, okay? So if I'm approaching 2 from the left-hand side, all right, it means that I'm focusing on the values of x less than 2, and the function that corresponds to that is x times e to the x squared minus 4 over 3 minus 5. Yes, so the function which corresponds to x being less than 2 is x times e to the x squared minus 4 over 3 minus 5, okay? So I need to use that function in order to find the limit of f of x as x approaches 2 from the left, okay? So this is equal to the limit of f of x. All right, so let me just scroll down a bit here. The limit of f of x, which is x e to the power of x squared. All right, e to the power of x squared minus 4 divided by 3 minus 5. All right, so the limit of that function as x approaches 2 from the left-hand side. Okay, great. So let us now calculate the limit. All right. Now, remember, when you're calculating the limit, it means that you have to use direct substitution. Okay. So you're substituting x as 2 into the expression here. All right, in the brackets. So I will have 2 multiplied by e raised to the power of 2 squared minus 4 over 3 minus 5, right? Just substituting x as 2, okay? Now I realize that when I substitute 2 into the power here for e, right, I will have 2 squared, which is actually 4, minus 4, so that's 0, divided by 3, which is 0, right? So my first term here will simplify to e, all right, e to the power 0, but I'm multiplying by 2. So that's 2 e to the power of 0 minus 5. Okay? That is what I have. And we know that e to the power of 0 has a value of 1, right? So what I have is 2 multiplied by 1, which is 2. All right, so that's 2 minus 5. And I can now say that the limit of f of x as x approaches 2 from the left-hand side, all right, on the left-hand side is equal to 2 minus 5, that's negative 3. Okay? Negative 3 is my answer. So I'm now finished with the first part of the question. Okay? Now I'm going to do the second part of the question, which says we are to calculate the limit of f of x as x approaches 2 from the right-hand side now. Okay? Let's go back to the real number line. So if I'm approaching 2 from the right-hand side, it means that I'm focusing on the values of x that is greater than 2. Okay? X greater than 2. All right, which is right here. And the function which corresponds to that is 3 cosine of pi x over 2. All right? So let me just write that down here. So we're at part 2 now, the limit of f of x as x approaches 2 from the right-hand side. This part 2 solution. So we want the limit of f of x as x approaches 2 from the right-hand side. So 2 plus. Okay, so this is equal to the limit of the function that we said is what? 3 times the cos of pi x over 2, right? That's the function which corresponds to x being greater than 2. So we want to find the limit of that as x approaches 2 from the right-hand side. Okay? Great. So using direct substitution now, all right, substituting x as 2 into the brackets here, you'll have 3 times the cosine of pi times 2 over 2, right? So you have 3 times the cosine of pi times 2, which is the same as 2 pi over 2, okay? And clearly we can see that the 2's here will cancel out, which will give me 3 times the cosine of pi, all right? Now, what is the cosine of pi? What is the cosine of pi? You should remember that from trigonometry, all right? So let me just do a sketch here. Just going to do a sketch here of the cosine graph, all right? Great. So here's going to be 0, all right? And I know that the graph starts at 1, okay? So it's going to have something like this. Okay? Where here is going to be -1. All right. So here, right there is going to be my angle pi/2 radians or 90 degrees. Okay. And here now is going to be my angle theta equals pi. Okay. So at pi, it means that the cosine graph is -1. All right. You could also use a calculator as well to get this answer. Okay. So this is equal to 3 times the cosine of pi, which we said is -1. All right. So this is just equal to a -3 now. All right. 3 times -1 is a -3. And that is my limit of f of x as x approaches 2 from the right-hand side. Great. So we're now finished with that. All right. Finished with the second part. Part 3 now says we are to find the limit of f of x as x approaches 2. Okay. Let's write that down. So at part 3. All right. So at part 3. Solution. And they ask us to calculate the limit of f of x as x approaches 2. Okay. Now, how do we do this now? Well, if you remember your knowledge from limits, in order for that limit to exist, all right, in order for the limit of f of x as x approaches 2 to exist, it means that the limit of f of x as x approaches 2 from the left, okay, so this value here, must be equal to the limit of f of x as x approaches 2 from the right. That value there. And clearly you can see that they are both equal, right? Limit from the left is -3, and the limit from the right-hand side is -3. So since both of those are equal, I can say that this is equal to -3. All right? Since, so I'm writing my reason, and the reason is because the limit of f of x as x approaches 2 from the left-hand side is equal to the limit of f of x as x approaches 2 from the right-hand side. Okay? That is my reason. All right? And you need to practice writing your reasons as well. Okay, so that is my answer for part 3 now. Great. Let's just know the part 4. Part 4 says we're to find f of 2, right? Meaning that we want to find when the function is defined at x equals 2. Okay? That is what we want. And when x is equal to 2, all right, this is when x is equal to 2, f of x equals the ln of x squared minus 3 plus x plus 1. All right? So let's just write that down. Okay? We're going to write that down now. So we're saying now part 4, solution, f of x equals the ln of x squared minus 3, okay, x squared minus 3 plus x plus 1, right? So plus x plus 1. And I want to find f of 2. So we're using this function here because this is when the function is defined at x equals 2, okay, from the piecewise function that we can tell. So we're going to substitute now x as 2 into the function. So we'll get the ln of 2 squared minus 3 plus 2 plus 1. Okay, so f of 2 equals the ln of 2 squared is 4, subtract 3 plus 2 plus 1, that's 3, right? Good. So let's just simplify now. F of 2 equals to the ln of 4 minus 3, that's 1, right? So the ln of 1 plus 3, and ln 1 has a value of 0, okay, plus 3. You can check it in a calculator. Ln of 1 has a value of 0. All right, so we have 0 plus 3, and therefore f of 2 equals 3. Okay, good. So although we're dealing with limits, I just wanted to also put a function question there, right? Because sometimes you may need you need that knowledge as well when you're dealing with continuity sometimes, right? So we have f of 2 to be equal to 3. All right, great. So we're finished with part 4. Now we're looking at part 5, which says the limit of f of x as x approaches 1. So this is part 5 now. So part 5, solution. We want the limit of f of x as x approaches 1. Okay? Now, let us look at our real number line. If I want the limit of f of x as x approaches 1, it means that I would have to focus on the part of the graph which says x is less than 2, right? Because we know that 1 is less than 2, right? 1 is less than 2, so it means that I need to focus on the values of x, or the function that corresponds to x being less than 2. Okay? So that's right here. All right? So we're focusing on that function, x e to the power of x squared minus 4 over 3 minus 5. All right? Good. So let us just write that down here. So the limit of f of x as x approaches 1 is going to be equal to the limit, all right, of x times e to what power? X times e to the power of x squared minus 4 over 3 that's x squared minus 4 over 3, okay? And we're subtracting 5. Okay, that is my f of x there. Great. So let us now use direct substitution. So we're substituting x as 1 into the function here. All right. So what we get is what? 1 multiplied by e to the power of 1 squared. All right. So we're going to have 1 squared minus 4 over 3 minus 5. Okay. So you don't have to write the ones because we know that 1 times that is e raised to the power of 1. 1 squared is 1, right? And 1 minus 4 is a negative 3, okay? So what we really have is negative 3 being divided by 3, which is actually a negative 1 as the power, all right? Minus 5, and that can be written as e to the power of minus 1 can be written as 1 over e minus 5, okay? And that's the limit of f of x as x approaches 1. Okay, that is my answer. You could also leave it as e to the power of minus 1 minus 5, right? But in maths, we don't really tend to leave our answers with a negative index. That's the reason why I converted it into a positive index by writing it as 1 over e minus 5. Okay? So that is my answer for part 5. Now, the last part of the question says that we are to find the limit of f of x as x approaches negative infinity. All right, what does that mean? So when the values of x get large, right, negative large values of x, what is f of x approaching? Okay, so let's go back to the real number line here. All right, so we want to approach negative infinity. Okay, So if I want to approach negative infinity based on what I'm given in the graph, right, with the piecewise function, it means that I need to focus on the function which says x being less than 2. Why? Because if I want to approach negative infinity is to the left of 2, right? So that is the reason why I need to focus on the function which says x being less than 2. Okay? X being less than 2, the same function that we have just worked with previously. All right? So let's just do that here now. That's part 5, and now we're at part 6. All right? Part 6 solution. So we want the limit of f of x as x approaches negative infinity. All right? And we know that our f of x here is x times e to the power of x squared minus 4 over 3. All right? E to the power of x squared minus 4 over 3 minus 5. Right? That is my f of x, right? Good. Just to calculate this limit now. All right. Now, we don't tend to write down the substitution, as in we don't really write down substituting x as negative infinity. All right. We don't really write that down. So what I'm going to do is just do it here to the side so that you can have an understanding of what we're doing. So let's say we're using direct substitution, right? And we're substituting x as negative infinity. So you have x here in front of the e, right? So that's negative infinity times e to the power of negative infinity squared, all right? So they have negative infinity squared here, right? Substituting x as negative infinity, minus 4 divided by 3, and we're subtracting 5, okay? So that's negative infinity times e to the power, all right? So let me not put equal to, we don't tend to write equal to, we tend to write the arrow, okay? So this is saying now that negative infinity squared, all right? Let's say you have a negative large number, right? A large negative number, and you're squaring that. It will become a positive number, right? It's still going to be large, but it's going to be a positive number, right? So that's going to be infinity, all right? Subtract 4 over 3 minus 5, okay? So that is now negative infinity times e to the power of now a large number, right? Minus 4 is still going to give you a large number. Divided by 3, still going to give you a large number. All right, so we're going to have infinity there. Minus 5, okay? So e to the power of infinity, what is that going to be? So I'm just going to draw the graph of e to the power of x so that we can see what we're dealing with here. All right. Great. This is my x-axis. All right. This is going to be my x-axis. This is going to be my y-axis. Okay. And I'm going to have my graph here. Okay. Where this point is 0, 1. All right. So this is the graph of y equals e to the power of x. Okay. So if you're approaching positive infinity, all right, so this graph continues on and on, right? This graph continues, okay? So if I'm approaching infinity, right? If I'm approaching infinity, right? Because remember that we have e to the power of infinity here, right? This is what we have. We have e to the power of infinity, right? And this is the graph for e to the power of x. Yes, this is the graph of e to the power of x, right? So if I'm approaching infinity, right, large values of x, right, large values of x, the graph will be always be up here, right? So the graph is shooting off to infinity, okay? So it means that, so what it means is that e to the power of infinity is going to approach infinity, all right? So what we have now is negative infinity here being multiplied by infinity minus 5, all right? Minus 5, good. And that is now approaching negative infinity times infinity. That's going to be negative infinity squared, all right, minus 5. And that is now going to approach what? Infinity squared is infinity, okay? So if I have a large number and I square it, right? If I have a large number and I square it, it's still going to be a large number, right? But I have a negative in front. So I'm going to have a large negative number minus 5, which is going to be a large negative number, right? If you think about it. So it's going to be negative infinity. So what I'm saying is that negative infinity times e to the power of negative infinity squared minus 4 over 3 is going to approach negative infinity, all right? So it means that this first part here in the brackets, the x e to the power of x squared minus 4 over 3, all right, minus 5, that is going to approach infinity, negative infinity, sorry, all right? So I can say that this approaches negative infinity, right? That's what we had, right? Yes, that's what we have. Oh, I forgot the negative 5 here, so let me just write it. All right, so subtract 5. Yes, that is approaching negative infinity. So the limit of x e to the power of x squared minus 4 over 3 minus 5 as x approaches negative infinity is approaching negative infinity. And that means that the limit does not exist. Okay? So this means that the limit does not exist. All right? Whenever you have your answer as approaching negative infinity or positive infinity, it means that the limit does not exist. Okay? Good. So that is my answer for the last part of the question, okay, which says find the limit of f of x as x approaches negative infinity. All right, I hope you understood everything that I did. Okay, if you did, please ensure to like up the video, all right, and comment down below. All right, I am Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.